Welcome. This is class 2. This class again will be 2 parts. I found out that my files were too large for the DePaul system, so I'm trying to deal with that by turning each class into 2 separate parts. So from now on, there will be at least 2 parts for each class, and this is part 1 of class 2. This class deals with preparing for your analysis. It's cleaning data, screening data, bringing in data, and also a lot more. Actually, we'll get into graphics and some other topics as well. But we're going to start with bringing in data and move from there. I will say, in the typical analysis I do, if the statistical analysis is going to take 1 hour, preparing the data often takes 7 hours. So preparing data takes a lot longer than the actual analysis. I think you'll probably find that as you go along. If you want to prepare your data correctly, it may take a lot longer than the analysis itself. And we'll be talking about why that is. Okay, so again, we're going to be talking about preparing, cleaning, and screening data. One thing I want to say right away is that when you go through this process, it's a good idea to create a new data file at each step. So if you're using SPSS or R, whatever you're using, it's better to create a new data file at each step. That way, if you have to go back, or if you do something wrong, you can go back to sort of your original file and see what you did wrong, and you still have the original data. I've worked with a lot of engineers who for some reason sort of adopted the view, well, if I've changed things, I can just get rid of the old data set or write over it. And I've always found that to be a mistake, because then you lose that original data. You also lose track of what you did with each step along the way, which is why it's important to document what you do at each step along the way, and why it's important to save your syntax and your output. I now understand that R makes it easy to do that. You have sort of project folders you can use with R that make it easy to do that. If you're doing it with SPSS, again, I recommend that you just, create sort of your own folders and save your in syntax and your output as you go along. All right, we're going to start with bringing in data. Bringing in data in SPSS is actually quite easy. If we go in the menu at the top to File, you'll see it opens up a number of choices, and one of those choices is Open. And then if we click on Open, it'll say Data, and we can use that then to bring in data. SPSS makes it very easy to bring in data from Excel and other places. Well, once we click on data, it'll ask us what file we want to get, and if we've told it an Excel file, it'll find the Excel files in whatever folder we're looking for the data in, and it brings them in pretty easily. I will say, really, Excel's more the problem than SPSS. I know a number of people who probably agree with me, some who disagree with me. I do not use Excel for statistical analysis. I just find it's too problematic. I think it's better for graphics, maybe even than R, but I don't use it for statistical analysis. It makes too many errors. I don't like how it treats missing data. There's a lot of other issues with Excel. When you bring data in from Excel into SPSS, you'll find there's a number of issues. So Excel has a number of unique properties itself that you should keep in mind whenever you import data. But anyway, we can import data by saying Open Data, or you can use the Import Data command that you see there as well. So you'll see there's both Open and then there's Import Data. And we can use either one of those. I always just use Open and then Data. Okay, if you click on Open Data, you'll see something like this. Look in a particular folder, and you'll see it'll tell us which files are of the type Excel. We can see our files. We can choose that file and open it. It'll even tell us, SPSS, what it thinks the data is going to look like as it brings it in. It gives us some choices. For example, what percentage of values will determine the data type, whether we ignore hidden rows and columns, whether we read the variable names from the first row of data. So you have a number of choices here. If you know Excel, you'll sort of know what that's talking about. You can make these choices. I usually lower the percentage of values that determine the data type. I forget how low SPSS will let you go, but I usually make it 90 or 80% because if you have a lot of funny data in your Excel data set, then your then SPSS might have trouble identifying what type of data you're actually using. Okay, once we bring our data in, we might want to merge data. For example, we might have data in two different data sets and we have to merge it. Or maybe somebody sent us data. Or we're working on a project and we have a demographic data set and a test data set. Merging data, again, is very easy in SPSS. You just say to merge data, you can merge either cases or variables. Both those options are found in the menu under data, but you can merge either cases or variables. If variables, you should always use a key variable. There's an option where you don't need a key variable, but I would never use that option. I would always have a key variable. A key variable is just the variable that you're matching on. Usually, for example, the ID of the subject or the social security number or the student ID. It's a good idea to sort on ID before you do your matching, but that's basically all you have to do. And then there's also an option where you can use basically one of the data sets as a lookup table, or a table that contains data that's to be matched to all the data in the other file. So if you know what a lookup table is or a lookup file, you can use one of your data sets as basically a lookup file and do a one-to-many merge then based on your key variable or your ID. So you can do what's called a one-to-many merge when you have one data set that's serving basically as a lookup file or a lookup table. Aggregating data. One of the things I like about SPSS makes it easy to aggregate data, although I guess R does this as well. But aggregating data is pretty simple. And by aggregating data, I mean, for example, for each person, I have 4 different cards or records. And I want to take the average of the 4 different records on the same variable. So I have 4 different cards or records for each person. I want to turn that into one case with the average of the 4 different records for the same variable. So for example, I have 4 supervisors, each rating each of you as a teaching assistant. And the 4 raters are on different cards or rows. What we could do is use aggregate to aggregate these supervisor ratings. So again, in SPSS, what we'd use is data, aggregate. We then select the break variable, which in this case would be TA. We select the variables you want to combine and how. And then one thing you should do is be sure to ask to write to a new file, or else you won't probably get what you want. So it's always a good idea to ask it to write the results to a new file. So again, you go to data in the menu, or the menu at the top, then aggregate, then select the break variable, in this case TA, and then select the variables you want to combine and how. In this case, we want to average them. So this might be what our data would look like originally. We have the TA, TA1. TA1 has 4 supervisor ratings. Here they are. TA2 has 4 supervisor ratings. Here they are. These are the supervisor numbers. These are the ratings. So the TA number, the supervisor number, and the ratings. We use, after aggregate, this is what the data file would look like. Would have TA1, supervisor average equals 3.5, which you can see is the average of these. TA2, supervisor average is 2.5, which is the average of these 4 numbers. So aggregation can be very useful because you can aggregate the results from different individuals or different raters, for example, or different time periods for the same person and get some kind of summary data point. Restructure is also very useful. Restructure is similar. It's a similar problem to aggregation, I think. But this time I want one row with all of the 4 different teaching ratings. So instead of wanting an average, I want to get one row that contains all of the teaching ratings. And SPSS gives you an option that will easily do that, restructure. Restructure actually uses a wizard. So if you click on restructure, it's going to take you to a wizard to help you do what you need to do. So SPSS restructure, again, click on data, then click on restructure. It'll bring up a very friendly wizard, and that wizard will help you through this process. And here's what the final result would look like. So we have, again, 4 TAs, 4 supervisors with ratings. So these are the TA IDs again. These are the supervisor IDs. And these are the ratings from the supervisors of the TAs. And what we want to do is get this all in one case or record. For example, maybe we want to calculate coefficient alpha or inter-rater reliability. And so we want it all on one record. So to do that, we just use restructure, and this would be the result. TA1 would have supervisor 1 rating 4, supervisor 2 rating 4, supervisor 3 rating 3, supervisor 4 rating 3. TA2 would have 1, 2, 3, 4, etc. for the rest of our data. So you can see how that would be very useful. It allows you to restructure your data, putting the data that's right now on separate cards for the same subject onto the same record or card. I'll probably use the word card again because, as I said in my technology lecture, I'm a little old-fashioned, and that goes back to when there actually were cards. But cards just means a row of data. Okay, so that leads us to our next big topic, which is cleaning the data. So why do we need to clean data? Well, because data is very rarely clean to begin with. It's usually quite dirty. There's usually people who started and stopped. I mean, just started and decided, oh, I clicked on this, but I don't want to participate anymore. So they really don't do anything in terms of your study. People who started did a few questions and then stopped. So maybe they did part 1 and then they stop because they get tired of it. There's people who might have too much or very critical missing data. There's people who might have confusing missing data that doesn't really make sense. There's people who are maybe too old, that should say too young, did not fit your participation guidelines. There could be other things, of course. Sometimes I see people who respond too early in terms of when supposedly I opened up the data, the study for participation, or too late in terms of when the study should have stopped. So they didn't fit your date parameters in terms of when you were collecting data. Of course, if you use mTurk or other data collection agents, you could have bots that are completing your surveys or your research or your questionnaire, and so you want to get rid of that bot data. You could have people respond too quickly. You could have people respond too slowly. You could have odd response patterns. You know, response patterns don't make sense. Somebody responds 5 to every question. Somebody responds 3 to every question. Of course, you could have other kinds of odd responses, like somebody goes 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, etc. So you can have lots of different odd response patterns. Especially if some of your data is being entered by hand or by coders, you could have data that's entered or coded incorrectly, where, for example, somebody had to obtain a score between 1 and 5, and they obtain a 13. And then one of the most common problems I find that can take a long time to solve is where IDs simply do not match up. Again, we talked about merging based on IDs. Sometimes IDs don't match up. If it's, for example, a multi-part study, somebody has to take the study over 3 different dates. Or maybe you're using real-world data from organizations or from a school. The person forgot their ID, or they type in their ID number wrong, and so they don't match up. What happens to me a lot is people who change their names, maybe between data collection 1 and data collection 2. Maybe they got married. Maybe they decided they liked a different name. Maybe they got a nickname. Whatever it is, they change their name, or they use a different name, or whatever it may be. So sometimes in your data, IDs or names don't match up. It could just be a typo. It could be because things changed for that person. But a lot of times you have to go through and say, well, hey, here's people who I merged two data sets. Here's cases that don't appear in both data sets. Why don't they appear in both data sets? Well, maybe the person was only in one data set, but maybe they're in both data sets, but they changed their name or put in a different ID number or whatever it may be. So there's a lot of things that can happen. So we have to clean all of that up. Okay, other than just manually going through things, what other tools can we use to clean data? Well, again, some of the things I find most useful start with the use of SPSS, descriptive statistics frequencies. So I think frequencies is very helpful in analyzing data. It allows you to see what data has been entered incorrectly, what data might have been entered correctly. So it allows you to look for a lot of problems. I mean, for example, if we see something like this, maybe this is a Likert scale. The only possible responses are 1 through 5. Well, we look at it and we have a -5 in our data. That should not have occurred. We have a 17 in our data. Well, we actually have 4 -5s, so none of those should have occurred. We have 2 17s in our data. Those should not have occurred. And we also have a lot of missing data. So we have to decide what to do about each of these. What do we do about the -5? How did that -5 occur? Maybe when I did a compute, I subtracted wrong. I've seen people do that a lot with Likert scales. For example, with reverse coding, if you're going to reverse code, you have to subtract your original variable from 6, not from 5. If you take 5 minus your original variable, you're going to get zeros when you shouldn't have zeros. So maybe somebody did something wrong where they reverse coded incorrectly, and that's why they got -5s. How they got a 17? Well, maybe somebody just typed something in incorrectly. Or maybe somebody just fell on their keyboard because they got tired. Who knows? But we have bad data in here, and we need to clean it up. Another very useful piece of software, I think, is SPSS, Descriptive Statistics Crosstabs, because crosstabs allows you to look and see whether, it allows you to look for certain combinations of data that are impossible. And of course, check and make sure that all the data that should match up does match up. So when you get to crosstabs, you'll find you have to make a number of different choices. I'm not going to go through those right now, but you make a number of different choices. But basically, you're creating a contingency table with crosstabs. So here we see a result from crosstab. This is something I'll use all the time. Maybe we've tried to dummy code sex or gender. And so we have males, females, and we have others. And so we also have a numeric code for males, females, and others. So we have two variables, one of which is a string variable or a character variable, where it actually says male, female, or other. And the other is a numeric variable, where it's 1, 0, or -1. Now, what should we find, of course? Well, we should find that these match up, right? That this cell, for ones that are males, there should be no females or others. Now, but when we get to females, we see, hey, there's actually 10 males who have a 0 code for females. So obviously something went wrong. And now we see for the -1s, which should be others, there's 1 male or 1 female. So again, things went wrong. So I like using crosstabs because, again, you can see these are all hopefully correctly coded data. These are incorrectly coded data. Something went wrong where we coded our data in incorrectly. And I can see that very quickly using crosstabs. Another thing I like to use is transform compute. So compute allows you to do a lot of different things in SPSS. But one thing I like to use it to do is to check and make sure, again, the data is clean. The data was entered properly. For example, maybe I've computed someone's total score in 2 different ways. I have the total score the teacher put into their grade book, but I also have their actual answers to the test. So I can create a second total score variable. So now what I can do is compare those two total score variables. One way to compare them, of course, is just to take total score from teacher's gradebook minus total score that I created. The result should always be 0. If it's not, I have a problem. So this is, again, something I like to use. There's other ways, of course, to compare that data. But this is just one thing I like to do to use as a check. When two columns of data should be the same, subtract one from the other and make sure everything is a 0. So for example, we've computed a difference. We've computed a variable called diff score. It's equal to the score recorded minus the score calculated. And so we compute this difference. And now what we've done is we've done a simple frequencies. And we can see that 1,000 times it worked. We have a score of 0. But 20 times we had a score of 2, 40 times we had a score of 100, and 44 times we had a score of 110. Or let's call it a difference score. So these are good data. These are bad data. We need to go through and figure out what went wrong that we computed our score incorrectly. Missing data. Missing data is a huge problem in analysis. The big problem is it just messes things up. It messes up the calculation of statistics. It can lead to deleting all of our data and telling us we don't have any data left to do an analysis. That's especially true if we use list-wise deletion as an option in SPSS. And if we don't have that big a sample size, we can lose valuable sample size. Or even if we have a large sample size, we can lose valuable sample size. So missing data is always a problem. In SPSS or R and E, and especially Excel, one of the things you have to do is be very careful that you study carefully and understand how missing variables are being treated. You know, I see a lot of people online posting that they have problems with this in R. I know people have problems with the SPSS, and it's a huge problem in Excel. So you always need to know how the software you're dealing with treats missing values. And there's some software like M Plus and other advanced pieces of software that just make the decisions for you, and you really have to be careful with those. So you always need to study carefully and understand how missing values are being treated. You also have to understand how different functions then and statistical analyses then deal with those missing values. So, for example, this shows you how SPSS handles various missing data. What I have, you can see I have 3 participants here. Participant 1 is missing the 5th variable. Participant 2 is missing the 5th variable. Now what we can see is 2 different ways that SPSS treats scores. So here we've just simply added up the scores. And so you can see when we add the scores, if we do a compute and we simply add the scores in SPSS, by add scores I mean we use a plus sign. It won't compute a score for subject 1 or 2, but it does correctly compute the 20 for subject 3. Now, if we had used the sum of scores instead, it would calculate the sum even if we have missing data, which might be what we want, but might not be. I mean, if this is a test, we might say, hey, if you miss a score, if you miss an item, if you don't do an item at all, you should get penalized for not doing it. It should count against your score. So maybe we believe these sum of scores are 10 of 10 are correct. But so you can see the difference. Adding up scores in SPSS will return a missing data point for subjects that are missing data. Summing scores will return a score for each subject But of course, that sum of scores will be based on only the first 4 variables for subjects who are missing the 5th variable. I hope you understand that. I hope you followed along with that. If not, when we get to the discussion, please ask a question. Now you can see 2 different ways of calculating the mean score. So I've basically done 2 different ways of calculating a mean score. But like, for example, here I've calculated, again, a mean score by taking the score and telling it to just calculate the mean. So in this case, you can see for the first 2 subjects, it does go ahead and calculate the mean, and that mean comes out to be correct. Okay, so you can see I've calculated the mean, and in each case, that mean, in fact, is correct. So it doesn't return a missing value here because I'm using sort of the mean function, and it's calculating the mean of the non-missing data. So it's calculating the mean of the non-missing data. Okay, continuing with missing data. You have an article that talks about this. One of your assigned readings talks about different kinds of missing data and treating it. And that article talks about 3 types. It talks about missing not at random data. And that's data that's missing, but systematic and depends on unobserved data. So for example, let's say we have a question in our survey that was, what was your father's income? Well, what happens to people who have no father, or have 2 mothers, or have more than 1 father, or who perhaps aren't sure who their father is? What do? Maybe they skip this question, so they have missing data. Well, that's sort of not ignorable missing data because the data is not missing at random. It's related to other variables that we have. So that's really non-ignorable data. We have a reading on this. We can talk about it more during the discussion. Missing at random data is systematic, but depends on observed data and therefore can be controlled. So for example, question, did you have a father in your house growing up? If we included that on the survey, if we included a question on the survey, did you have a father in your house growing up? Now, if the person says no, that tells us something about that missing data for the what was your father's income question. So again, the missing data is on the what was your father's income question. But now we know something about why that data is missing because we asked the question, did you have a father in your house growing up? So in that case, the missing data sort of becomes ignorable. By ignorable, I mean, we can probably just go ahead and calculate averages or however simple method we want to use to handle the data. But providing the observed data is properly controlled for the analyses, it's more ignorable than the data that's considered missing not at random. And why that's called missing at random, since it's still systematic, I don't know. Those are the titles that the article gave to these different kinds of missing data. Then we have data that's missing completely at random. There's no problem no real pattern to the missing data. For example, maybe people missed certain items because the computer malfunctioned and never showed them that item. Or maybe the computer went down and they didn't see that data. Whatever it might be, we can regard that as sort of being, again, ignorable missing data. But we'll be talking about missing data a lot more. You have an article that deals with it quite a bit. There's a number of different ways to handle missing data. It's a complex topic. So again, we have quite a few readings that deal with the topic of missing data. Although you'll probably see those readings suggest using pretty simple solutions. So again, in terms of missing data, there's different ways of handling it. most of the time as parent, that's the one article, Parent 2013 suggests you can just use available item analysis. That means you just usually use pairwise deletion. You tell SPSS or whatever the program is, use pairwise deletion. You basically sort of skip over the missing data, or you can calculate the mean of a scale or subscale rather than the total score. Or, and these can of course be used when missing data is either low or infrequent, or it's either MCAR or MAR types of missing data. Now, again, as I said before, one of the things you should be sort of wary of is that some statistical packages automatically replace missing data using approved techniques, such as M+ for structural equation modeling and other types of similar software. So there is some software, especially structural equation modeling software, that will just replace missing data automatically. And I will say SPSS also allows for fancier types of imputation of missing data. I sort of like that word imputation. You'll see I use it a lot. But SPSS does allow for fancier types of imputation. I said I like the word, so you see it's on the next slide again, imputation. What is imputation? In statistics, imputation is simply the process of replacing missing data with substituted values. So that's all it really means. It's just you're replacing missing data with substituted values. It could be the mean, it could be some regression estimate. There's a lot of different ways to do imputation, but that's all it is, replacing missing data with some other value, and that would mean, of course, the data is no longer missing. So you can see again in SPSS, there's a number of ways to get rid of missing data. You would, again, in your menu, you would go to transform, and then you would go to one of the choices for missing data. Where are they down here? Replace missing values, for example, is one of those. So you can see transform missing, replace missing values right down here. You can also just recode missing data using either recode into same variables or recode into different variables. I would caution you right now, I never use recode into same variables. I think it's dangerous again to recode into the same variables. Hopefully if you're doing that, you've already saved your old data set in case you make a mistake. Even then, I don't like recoding into same variables. What I'll always do is create new variables to handle the recodes. So if I am recoding, I'll use recode into different variables, never use recode into same variables, just my personal opinion. And but anyway, when we're dealing with missing data, probably what you're going to do is use this replace missing values right down here. So again, to replace missing values in SPSS, go to transform, replace missing values. Then you'll see there's a number of different choices. They're pretty basic choices. Right now, I'm not going to go into those. I mean, if you want to discuss them, we can discuss them in the discussion section. And I even had a little transformer here for you to make you remember that it's transform. SPSS does have other even fancier ways to deal with missing values. For example, if you go to Analyze and then Multiple Imputation, you'll see there's options for different kinds of imputations there. So there's what's called Analyze Patterns. There's also, you can also do impute missing data values there. And there's another option you can see that's called Missing Values Analysis that allows you to analyze for what types of missing values you might have. So really, SPSS has quite a few different ways of handling missing data. I don't use these very much, to be honest. I would say probably you're not going to get into this kind of multiple imputation unless you're dealing with big data. I mean, the new version of IBM is when IBM took over SPSS, it's now made to handle big data analysis of various kinds, in theory. But I think primarily you'd be using this multiple imputation options if you're dealing with big data. So probably for what we're doing with regression, it's not something you would need to worry about. Okay, next we'll be talking about screening. When we talk about screening, you'll see I've created a database. So I'm going to use slides from Field, but I also have my own database I created, or data file. It's a COVID data file. I thought that was sort of interesting and timely. It's state data, so the cases or the subjects are states rather than people. And it's created from real world data. So I went out and got a number of different real world data points. I did it just 2 days ago. So it's very recent data. Uh, and so we'll be using that COVID file for a number of analyses throughout the semester, including talking about screening data. So our next topic is going to be screening data, but where that'll be on part 2 of this second lecture. So thank you. That brings us to the end of part 1 of preparing for the analysis. You will be now moving on to part 2 of preparing for the analysis. Thanks very much, and we'll see you in part 2.